Hello everybody, it is my pleasure to bring you a couple of examples in projectile motion. In this first example, a cannonball is fired horizontally from a height of 12 meters to hit a target 23 meters from the base. We are required to calculate the launch speed and the speed at impact. Now, we've been asked to calculate the initial velocity. I'm just going to call this V naught. We don't know that. And we need to calculate the speed of the projectile V at impact. What do we know? We know that the height h is 12 meters, and we know that the range r is 23 meters from the base. Now, in this example, I'm going to take my origin right here. This will be my origin. So we will analyze the vertical motion separately as well as the horizontal motion separately. So let's recap the main points. We have a projectile which is launched with a certain speed v naught. It follows a parabolic path to hit a target, and we are required to calculate the speed v at impact. We also need to calculate the initial speed. We know that the height h is 12 meters, and we know that the range r is 23 meters. So this is a projectile motion, which means that the only force that acts on this particle is the force of gravity, which acts vertically downwards. That means that the acceleration in the horizontal direction is 0. Now the acceleration in the y direction is just negative g. We are taking the upward direction to be positive. And if the acceleration in the x direction is 0, that essentially implies that the velocity in the x direction does not change, but the velocity in the y direction changes. So if we consider the vertical motion of the projectile, we know that initially we're going to take the origin to be at that point. So we will have initially y naught therefore is 0. V o y, the initial velocity in the y direction, is 0, and the acceleration in the y direction is just negative g. So what do we know? Generally, v is equal to v naught plus at, which means that vy is equal to voy plus ayt. But in the y direction, the initial velocity is 0. Therefore, generally, vy will be equal to negative g multiplied by t. So this expression right here shows us how the velocity in the y direction changes. Now, similarly, we know that generally y is equal to y naught plus voyt plus 1/2 ayt squared. Now, initially the particle is at the origin, so that makes us 0. The initial velocity in the y direction is 0. So this would mean, remember that we are taking the upward direction to be positive, which since the particle is moving downwards, y is negative. So this is negative y equal to negative 1 half gt squared. This will give us y to be equal to 1 half gt squared. This expression right here tells us how the vertical displacement varies, or the vertical position varies with time. Now we've been asked to calculate the initial velocity, which is an x velocity. So we know that Vx in the x direction is equal to Vox plus axt. The acceleration in the x direction is 0. That means that Vx is just going to be equal to V naught, which is exactly what we are actually looking for. Now, similarly, x is equal to x naught plus Vox t plus 1 half axt squared. There is no acceleration in the x direction, that is 0. The particle is at the foot of the table, which is essentially the x coordinate is 0. This would imply that x is just going to be equal to V naught t. This expression here tells us how the horizontal displacement varies with time. Now, the next thing would be for us to calculate the time, because we know that the range r, which is 23 meters, is equal to V naught t, where t is the total time. We don't know t, but we are looking for t naught. Similarly, we know that the height h is going to be equal to 1 half g capital T squared. So using this expression, we can calculate for capital T and then substitute it in this expression to determine V naught. So T therefore will be equal to the square root of 2h over g, which would mean that T is equal to the square root of 2 multiplied by 12 divided by 10. This is 24. So T essentially is just square root of 2.4. Hence, R, which is equal to V naught T, would imply that V naught will be equal to R over T, which is equal to 23 meters. 23 meters, all divided by T, which is the square root of 2.4 seconds squared. So V naught will be equal to 22.4 square root. That's 1.55. So 23 divided by 1.55. That will give us 14.84 meters per second. This is the initial velocity of the particle. Now to count, this is the initial speed. To calculate the speed at impact, V is equal to the square root, just like I showed you before, VO squared plus VY squared, where Vy is equal to negative G capital T, and V naught is just gonna be equal to V naught. It doesn't change. So V will therefore be equal to 14.84 all squared plus, remember that T is 1.55 multiplied by 10, that will be 15.5. So this will be negative 15.5 all squared. That will mean that the speed at impact will be equal to to 21.46 meters per second.